Hi guys, welcome to another video. So today we're gonna cover exercise 7.3 of class 12 NCERT integration. So without wasting any further time, let us start and make sure to like this video and comment on it if you can. It would really help me out. All right. So getting right into it, the first question reads sine squared 2x plus 5 dx. Right. In this question, you may use substitution and take the argument to be your new variable and solve it in that manner. But I find it unnecessary to do that, and I'm simply going to use the formula well, of cosine 2x, and this one in particular, because we see that here we have sine squared something, and here we have sine squared something. So just redistributing, so sine squared x is of course equal to 1 minus cosine of 2x over 2. So making substitution here, um, this of course is equal to 1 minus cosine, and here we have a cosine 2x, right? And here the argument is not x, but it's 2x plus 5. So it's going to be cosine of 2x plus 5 over 2 dx. I'm going to take this 1 by 2 outside the integral. So 1 by 2, and then I'll just have cosine of 4x plus 10 dx. This is distributing inside. All right. And now we can integrate because we have two separate terms with the power 1, so we can easily integrate. So this is going to be half stays a half. The integral of 1 is x, and for cosine of 4x plus 10, it's minus, because the minus is here, and then sine of 4x plus 10, and we have to remember to divide by the derivative of this because of the inverse chain rule. The derivative of 4x plus 10 is 4 and the plus c. We can just distribute this out. That's going to be x over 2 minus sine of 4x plus 10 over 8 plus c. That is the answer. All right. So now the second question is sine 3x cosine 4x. All right. So in questions like these, where you have sine of something times cosine of something, what you want to do is you always want to keep the term with the larger argument in the front. So here we have a 4x, here we have a 3x. So what I like to do is I like to rewrite this as cosine 4x sine 3x. And now we have to recall a trig formula we learned earlier, which is sine x plus y minus sine x minus y is 2 cosine x plus y times sine x minus y. Right, and here we do have this, and we just don't have a 2, but that's okay because we can just shift it to the other side, right? And what I'm going to do is I'm going to multiply and divide by 2, so we get a 2 there. Just like so. And now we see that we do have this form right here. So I'm going to convert it to this form so it can easily be integrated, because here we have a sum or a difference which we can just integrate separately. So right, I'm just going to write that as sine of, well, it becomes 4x plus 3x, right? From 7x minus sine of x dx. Right. And now, oh, I'm so sorry. I just wrote this wrong. This is not, that's just x and that's just y. And now it's correct. I'm so sorry. Right. And now we just want to integrate separately. It's going to be negative cosine 7x over 7 because of the inverse chain rule. And similarly, that's going to be positive because of the double negative then. Because there's a negative here and that's negative cosine x. It's going to be positive cosine x plus c. And now I'm just gonna, well, multiply it out. Negative cosine 7x over 14 plus cosine x over 2 plus c. And yeah, that's the answer, I believe. All right, moving on to question number 3. Question number 3 is very similar to this one, but it just has 3 terms instead of your normal 2. So I'm just gonna write that down. So question number 3 is the integral of cosine 2x, cosine 4x, cosine 6x dx. Here again, we're going to use a formula from this family right here. And here we have three terms in terms of cost, but we're going to pair two of them first. So we have cos of something times cos of something else. So that reminds us of the formula cosine x plus y plus cosine x minus y is 2 cosine x cosine y. And now again, we don't have a 2, so I'm just going to multiply and divide it out by 2. And usually for these questions with 3 terms, I like to take the bigger 3 terms in this identity just because it gets easier. No, it doesn't really get easier at the end, but just gets easier to calculate, if you know what I mean. So I'm just going to take the 2 here so that we can get rid of the cosine 4x and the cosine 6x. And now we can see that this term becomes that. I'm just going to write that down. Times cosine, add these two, 10x plus subtract these two, that's cosine of negative 2x, but you know that cosine of negative something is just, we can just get rid of the negative sign because it's an even function. That's just going to be cosine of 2x with respect to x, of course. And now we're just going to multiply this out. That becomes cosine 2x cosine 10x plus cosine square of 2x dx. Now I'm going to split the integral. And now I'm just gonna split it right here on the side. Right, and now we're just gonna write this part. Again, we're gonna do the same thing. We're gonna use this formula. So we're gonna have to multiply and divide by 2 once again. So because there's already a 1 by 2 here, that just becomes a 1 by 4 after we divide by 2 outside. And the inside, well, there's a 2 here now. And again, we're gonna use that formula. So that's just gonna be cosine of 2 plus 10, 12x, plus cosine of 2 minus 10, that's minus 8, but it becomes 8 because cosine is an even function, right? And for the second part, we're gonna use, well, we know that cosine square of something is equal to 1 plus cosine of this using the cosine 2x formula. So I'm just gonna write that. And because there's a 2 here, I'm so sorry, because there's a 2 here that goes outside the integral, and because there's already a 2 here, it's going to become a 1 over 4, and that's just 1 plus cosine of, here we have x and here we have 2x, but in our case we have 2x. That's just going to become 4x since we are doubling, respect to dx. And now we're ready to integrate because everything is a separate term. So that's going to become 1 over 4 and sine of 12x over 12 plus sine of 8x over 8 plus 1 by 4 of x plus sine of 4x over 4 plus c. And now we're just going to write that out. Sine of 12x over 48 plus sine of 8x over 32 plus x over 4 plus sine of 4x over 16 plus the c. Right. And that is your answer. All right. Moving on to the next question. Next question we have sine cube 2x plus 1 dx. And here we're going to use a very important identity again from class 11, and that's sine 3x. This equals 3 sine x minus 4 sine cube x, as we know. Just rearranging because we have a sine cube something, so we want to isolate a sine cube from here. So just rearranging, this becomes, of course, 3 sine x minus sine 3x over 4. And that is equal to sine cubed of x. I'm just going to write that down here. So 3 sine, and here we see that instead of x we have a 2x plus 1. So that becomes a 2x plus 1. And the minus sine of, then we instead of 3 times x we have 3 times this. So 3 times 2x plus 1 is of course 6x plus 3. I'm just going to write that down. And then we have all of this over 4 with respect to x. Just taking the 1 by 4 outside, and then we are ready to integrate. So I'll write that down. Right, and now we're ready to integrate. So I'm just going to integrate this. And that's going to become, oh, there's a 3 here. Right. 1 by 4, the 3 remains unchanged. Then the integral of sine of something is negative cosine. I'm just going to push the negative outside. Negative cosine of 2x plus 1. And then, of course, due to the inverse chain rule, I'm going to divide by the derivative of this. Similarly, here we'll have a minus cosine of this, and there's already a minus, so that's just going to be a plus cosine of 6x plus 3. And I'm going to divide by the derivative of this, which is just 6. I'm just going to write this out. And yeah, that'll give you minus 3 cosine of 2x plus 1 over 8 plus cosine of 6x plus 3 over 24 plus c. And alright, so this answer might not match the one that's given in the book, but nonetheless it's correct. It's just because different methods were used, and these answers, all of these answers can be changed into each other by using trigonometry. Alright, for the fifth question, it reads sine cube of x times cosine cube of x with respect to x. Whenever you see sine and cosine in the same power, always just push the power outside. What I mean is just write it in this manner. Now you see, whenever you see a sine x times a cosine x, you always want to remember this formula, which reads sine 2x is 2 sine x cosine x. So we almost have this, we just require a 2 inside, right? So for the 2, I'm just gonna multiply and divide it by 8 in this case, because it's being cubed, right? And we want it inside the bracket. So if we multiply and divide it by 8 outside, we can like this. If we multiply and divide by 8 outside, we can write this 8 inside as 2 cubed, and that will fit this form, right? I'm going to take 1 by 8 outside. Since we're multiplying by 8, I'm just going to write that directly inside the bracket. 2 sine x cosine x whole cubed dx. Now we can just rewrite this as sine 2x. That becomes 1 over 8 sine cubed of 2x dx. And now we're going to use the formula we just used here in this case. So it was 1 over 8 and 3 sine of x, but here x is 2x. So it's 3 sine of 2x minus sine of 3x, but here x is 2x, so it's gonna be 3 times 2x, which is 6x all over 4. So I'm just gonna push that 4 outside, so 1 over 32, and we can integrate already. So since 3 is a um, coefficient, we don't integrate that, so that's just gonna be a 3. And for sine 2x, it's gonna be negative cosine 2x over 2. For sine 6x, it's gonna be, because it's gonna be a negative from here, and there's already negative here, they make a positive of cosine 6x over 6 plus c. Now I'm just gonna multiply this out. So that becomes minus 3 cosine 2x over 64 plus cosine 6x over 192 plus c. And again, this answer may not match the one that's in the NCERT, but nonetheless, both of the answers in the NCERT and this one are perfectly correct, and you will get marks. So whatever comes naturally to you. The other method for this question um, is just using substitution. So for the other method, I'm just going to give you a hint to the other method, and you can maybe try it out yourself. Since this was the question, for the other method, we just want to segregate one of the sines or the cosines. For with sine, it's easier, so I'm just going to take that. And now we're gonna use cosine x as t. So sine x, so negative sine x dx becomes dt. And here we have a sine x and a dx, so we can just substitute. So I encourage you to try using that method as well. All right. Sixth question is similar to the ones we just attempted a while back. And the sixth question is sine of x times sine of 2x times sine of 3x dx. Again, we have the multiplication of three different sine terms, but here we're just going to consider two at a time. What we're going to do is we're going to use that formula again. These ones, which no one really learned last year actually, because they were the least useful in my opinion, at least for last year's trigonometry, but now they're very useful. So we have this, and we do have a two sines, but we don't have a negative 2. So we're going to multiply and divide by negative 2 just so it fits our form. And again, we're going to use the terms with the highest argument just because it makes things easier for, at least for me. You can do this with any two. We can pair up these two or even those two, and it won't make a difference. It'll just lead to the same answer. But I find this the easiest. And that becomes cosine of x plus y. So that's sum of these two, 5x minus x minus cosine of x minus y, just minus 1, but because cosine, it just becomes a plus 1 dx. Now we want to multiply this out. Sine x cosine 5x minus sine x cosine x. Um, right. And now we just want to what we're gonna do is split the integral again. I'm just gonna split it here, and I'm gonna change the order because the highest argument one should go first. Cosine 5x sine x dx. And here's a minus, there's a minus, so it's gonna become a plus half of sine x cosine x dx. And now for this, we're gonna use one of those formulas again. And I'm not gonna write the formula again, but you can scroll. We just used it in a question. So for cosine, this is gonna become 2 times 2 because we need a 2 here, right? And alright, so that becomes the integral of sine of 6x minus sine of 4x dx, since we added these two and then we subtracted those two, plus, and again we're going to introduce a 2 here just so it matches the formula for sine 2x. And now we're ready to integrate. So I'm just going to integrate it. That becomes a negative cosine 6x over 6, and that becomes a double negative, so a positive cosine 4x over 4, and that becomes a negative cosine 2x over 2 plus c. And now we're just gonna rewrite this, so that becomes cosine 6x over 24 minus cosine 4x over 16 minus cosine 2x over 8 plus c. And that is the answer. All right. Now for the next question. Next question, of course, is, and that's an easy one. All right. So the next question is sine 4x sine 8x. Again, this is the same form, and we're going to do the same thing again. So here we have two sines. So the formula for that is this one. So we need to multiply and divide by negative 2. You needn't write this step, the one I'm writing right now, in your exam. It's unnecessary. You can just write this and move on. This becomes a cosine 12x, since 4 plus 8 is 12, minus cosine 4 minus 8, so that's minus 4. That just becomes a 4 because it's inside a cosine function, dx. And now we're just going to integrate this. That becomes sine 12x over 12. That becomes sine 4x over 4 plus a c. And now I'm just going to write that out. And that is the answer. All right. Okay. Now for question 8. Right. So question number 8 is 1 minus cosine x and plus cosine x. And for this, we're gonna recall that the cos 2x formula, or the many different variations of this formula. So that's 1 minus 2 sine square x, or 2 cos square x minus 1. And using these, we can isolate 1 minus cos x. So if we just, so 2, 2 sine square x is 1 minus cos 2x, and 2 cos square x is 1 plus cos 2x. Here we just have a cosine x, so each angle is going to be divided by 2. So the top now we can see becomes this, or that. This cancels, it's just 1 minus cosine x is equal to this. So I'm just going to write that as 2 sine square x over 2, and the denominator, since this cancels out, becomes this. And now we can see that this 2 and that 2 cancel, and the integrand just becomes tan square x over 2 dx. For anything of tan squared, while integrating, you want to write it in terms of sec squared using, well, that identity. So I'm just going to write that as sec squared x over 2 minus 1 dx. And now we can integrate this separately because we know that the integral of sec squared x is tan x. So for sec squared x by 2, it's tan x by 2, but we also want to divide by the derivative of the angle because of the inverse chain rule. So that becomes 1 over 2 divided by 1 over 2 minus x plus c. And now this 2 jumps up, so it's 2 tan x over 2 minus x plus c. And that is the answer. All right. And now for question 9, you'll begin to see a trend in this exercise, that is these formulas, the ones with this and the cos 2x formula and the sin 2x formula are the most important, along with, of course, the sin 3x formula. All right. So for question 9, that's cosine of x, 1 plus cosine of x. And again, we're gonna have to use the cosine 2x formula in two different forms of it. So we know that cosine 2x is cos square x minus sine square x. Therefore, cosine of x is cos square x by 2 minus sine square x by 2. And similarly, 1 plus cos x is just 2 cos square x over 2. So I'm just going to rewrite the integrand as cosine square x over 2 minus sine square x over 2, and this has 2 cosine square x over 2 with respect to x. Now we're going to split the fraction as you always want to do when we can. So the first part becomes that, and here the cosine square x by 2 just cancels. It's just the integral of 1 over 2 dx. And right, and for there it becomes minus of tan squared x by 2 over 2, since this is what is there. So that just becomes a x over 2, right? And that becomes a 1 over 2 sec squared x over 2 minus 1 dx. And again we can integrate, and with the inverse chain rule, that's going to be 2 minus x. And right, so and that's like this. So x over 2, just opening this up, this 2 and that 2 cancel out, but we still have a 1 by 2 with this term, remember. So that's going to be minus tan x over 2, and a minus half times a minus x, so that's plus x over 2 plus c. And we're going to combine the like terms, so this and this get added up to make x minus tan x over 2 plus c. And that is the answer. All right. Now for the 10th question. So for the 10th question, there are a number of methods for each of these questions, by the way. So yeah, you may use a different method. That's perfectly fine as long as you get the right answer, of course. And all right, so since the next question is a cosine for 2x, I'm gonna use two different methods for these questions. So the first one is by using the cubic formula. So I'm just going to do that. So that's just sine cubed of x. I'm going to break this up into cubic and linear parts. Now I'm just going to rewrite this as what we learned earlier. So that's just 3 sine x minus sine 3x over 4, and of course there's a sine x here, dx. This 4 is just gonna get kicked out of the integral, and I'm gonna multiply these out by the sine x. So that becomes 3 sine squared x minus sine 3x sine of x dx. And we're gonna split the integral and use the cosine 2x formula again. So I'm just gonna take this 3 outside since we're splitting the integral. Just gonna get that, I'm sorry. Yeah, that becomes a sine squared x. So sine squared x is of course equal to 1 minus cosine 2x over 2. So I'm just gonna write that 1 minus cosine 2x over 2 dx, and that becomes a 1 by 4. And here, since we have two signs again, we're gonna multiply by -2 and divide by -2, just so we can have the good old formula again. If you just want to look at it again, this one, so that we can just multiply by -2 there down there, and this -2 sine of 3x sine of x dx. And now I'm just gonna take this 2 outside here, become a 3 by 8, and I'm gonna integrate. So the integral of 1 is of course x, and for negative cosine 2x it's negative sine 2x over 2. Then here this minus and that minus cancel out, so a plus 1 over 8, and this becomes the integral of cosine 4x minus cosine 2x dx. And now I'm gonna write this out in the process, and I'm gonna integrate here. So that's gonna be 1 over 8 times sine 4x upon 4, because for cosine 4x that's the integral. So sine 4x upon 4. For negative cosine 2x, it's of course negative sine 2x over 2. So negative 1 over 8 sine 2x over 2 plus a c. And I'm just gonna clean this up. It becomes 3x over 8 minus 3 sine 2x. Again, the answer may be different from the book, but it doesn't really matter as long as it's correct, because they will be interchangeable by using trigonometric identities. And that is the answer. Alright, now as I told you, there's two methods to this type of question. So I'm going to use the uh, other method on the next question, just so you can learn to do both. Next question is cosine of 4 2x dx. And now I'm going to split it using quadratics. That's just going to be cosine squared 2x times cosine squared 2x. And now I'm going to write one of them as 1 minus sine squared 2x, since cos squared x plus sine squared x is equal to 1, and it can be any argument. And now now this is a substitution, right? So I'm gonna let sine squared, sine 2x is equal to t. That gives me 2 cosine 2x dx is dt, if you differentiate both sides. And here we have a right, and here we do have a cosine, and we're gonna split this further, by the way. Um, yeah, wait just a second. Actually, no, I recommend following the first method for this question as well. There is another method, but I'm not comfortable with it, so I'm not gonna waste your time trying to teach you the method because if I don't know the method properly, how can I teach you, right? So I'm just gonna stick to the first method. So that's just gonna be cos cubed of 2x times cos of 2x dx. And now we're gonna write for cosine cubed of x, um, for cos 3x, we're gonna use this formula. It's 4 cosine cubed of x plus 3 cosine of x. And I believe that is the right formula. Um, right. Oh, I'm so sorry. That's minus, of course. Right. And now rearranging for cosine cubed of x, we're gonna get cosine 3x plus 3 cosine x over 4. So I'm gonna make the substitution here, and of course, here x is 2x. So since there's a cos 3x here, that becomes a cos 3 times 2x, so that's a cos 6x, and 3 cosine x means 3 cosine 2x over 4 times cosine 2x dx. Right. And now we're gonna just kick the 1 by 4 outside and multiply this out. So this times that is cosine 6x cosine 2x, and we're gonna split the integral as well. And 3 cosine 2x squared. And now we're gonna calculate. And here we have a cosine something times a cosine another thing. So we'll use that formula again. I'm just gonna write it this time actually. That's 2 cosine x cosine y. And we don't have a 2, so we can just multiply and divide by 2. We can just write this as 1 by 8 times cosine 8x plus cosine 4x dx. And again, I'm just gonna take the 3 outside, and since cosine squared 2x is 1 plus cos 4x over 2, I'm just gonna take this 2 outside as well. So that's just gonna give me 3 over 8 this time. And the integral is of course 1 plus cos 4x. And now we're ready to integrate. So I'm just gonna integrate 1 over 8. That becomes sine 8x over 8. That becomes a sine 4x over 4. And that becomes a x plus sine 4x over 4 plus c. So that becomes sine 8x over 64 plus sine 4x over 32 plus 3x over 8 plus 3 sine 4x over 32 plus c. And now this and that is a like term, so I'm just going to combine it. Sine 8x over 64 plus 3x over 8. Combined, that gives you 4 sine x upon 32, so that's just sine 4x upon 8. And that is the answer. Alright. Next question reads, question number 12, which is sine squared x over 1 plus cosine x dx. And I just want to take a second and allow you to think what we can do in this question, right? So we want to replace sine squared x with something, so it becomes it becomes so that we can integrate it. So just thinking, what's sine squared x? Of course, it's negative. Sorry, it's 1 minus cos 2x over 1 plus. Oh, sorry. It's 1 minus cos squared x upon 1 plus cosine x dx. And now we have a difference of two squares in the numerator. So we're just going to factor it out as we know that a square minus b square is a minus b times a plus b. So here it's going to be just that over 1 plus cosine x dx. And now we can cancel that out. So we just have the integral of 1 minus cosine x, which we can evaluate simply to be x minus sine x plus c. That is the answer. All right. So for the 13th question, is the integral of cosine. I want you guys to mark this particular question as important. Cos to alpha over cosine x minus cosine alpha dx. In this question, you want to memorize this approach, by the way. What we're going to do is we're going to expand these out. Since there's a minus sign in between, and the whole question is in terms of cosine, I'm just going to expand those in terms of cosine. That just becomes 2 cosine squared x minus 1 minus 2 cosine squared alpha minus 1 dx over cos x minus cosine alpha. Now that one and that one cancel out since there's a minus in between, so that becomes a plus 1, and it cancels out with the minus 1, and we just have a 2 cosine squared x minus 2 cosine squared alpha. So the 2 is common, therefore it's outside. This becomes cosine squared x minus cosine squared alpha over cosine x is cosine alpha dx. And now again we're gonna use the difference of squares to factorize this out. That's a cosine x plus cosine alpha, then a cosine x minus cosine alpha dx over cosine x minus cosine alpha. That and that cancel. So now we can just have a simple integral of 2 times. So the integral of cosine x with respect to dx is, sorry, I'm integrating, is sine of x, and cosine of alpha in the x world is a constant. So it's just a constant, so we're going to integrate like a constant. So we're going to integrate like we integrate 5, for example. So we know that this is equal to 5x plus c. So that if 5 is cosine alpha, that becomes x cosine alpha plus c. That is the answer. All right. So now for question number 14. Um, right. So question number 14 is the integral of cosine x minus sine x 1 plus sine 2x dx. And I want you to think back to inverse trigonometry. And we learned that 1 plus sine 2x is sine squared x plus cosine squared x plus 2 sine x cosine x, because we can just write 1 as sine squared x plus cosine squared x. So what I'm saying is 1 plus sine 2x equals sine squared x plus cosine squared x plus 2 sine x cosine x. And this looks familiar because, well, it's just the identity for whole square, right? So that's sine x plus cosine x whole squared. Just writing this out, um, that becomes that, and now we're going to use a u sub. So let sine x plus cosine x is equal to t. That gives you cosine x minus sine x dx is dt, which we have in the numerator. That's just, the numerator becomes dt, denominator becomes t squared, so I'm just going to write that as t to the power minus 2. Using the power rule, we have t minus 1 plus c, and t was, of course, sine x plus cosine x to the power minus 1, and that becomes a minus plus c. So we can just write that as minus 1 over sine x plus cosine x plus a c. All right. All right, guys. So big issue. I just recorded the entire rest of the exercise and I realized my mic was off the whole time. So I'm just gonna talk over the rest of the exercise if you don't mind that. All right. I apologize for this, by the way. So in this is question number 15, and what we did was this was the question, and we split it up into tangent squared of 2x as we see here, then a tangent 2x, then a secant 2x dx, as we always want to do with a question involving tangent x and secant x. And now we split the first tangent square x into this, and we let it be t. So of course the derivative of secant 2x will be secant 2x tangent 2x, and by the chain rule we're going to multiply by the derivative of the inside. So that is what I've written out here. I'm so sorry for this not being live. So, and we don't have a 2, so I'm just going to divide by 2 outside the integral, so we can assume we had a 2 and go on, since, this is what we did essentially. And the all of that becomes dt, and this of course becomes t squared minus 1. And so the integral using the power rule is this, and then we just replace the value of t. All right. And now for the 16th question, this was the question. And what we did was we broke it up into two tangent squared x, into two pairs of tangent squared x. And we wrote one of them as secant squared x minus 1. Just gonna check if we're recording, by the way. Yeah, we are. Then we multiplied it out. So the first term became secant squared x times tangent squared x, and the second term became tangent squared x. And now, as always, with a question involving secant and tangent, we want to take tangent to be t. So we take this, and secant squared x du becomes dt, right? And so that and that became dt, and this became t squared. That's what I've written out. And for this, we broke it up again into this. So here in the first integral, we use the power rule, so t cubed over 3, and in the second integral, we just integrated separately since we know both of these integrals. Then we replace the value of t. All right. Now for the next question. So what we did in this question was we broke the terms up. So we wrote this as a separate integral, and then we wrote that as a separate integral. So I'm just going to do some rough work on the side. So that becomes sine cubed x over sine squared x. The solution is in blue, by the way, and then a cosine cubed x, sine squared x, cosine squared x, and then sine squared x, cosine squared x. And this is the integral we have, of course. So here we see that that and this power gets cancelled, and then since this is a pair of cosine x at the bottom as I've written out here, one of them becomes a tangent x and the other goes up to the numerator to form secant x. So we have a tangent x secant x in the first term. For the second, cosine squared x and this power cancel, and then we have a cotangent x from here, and this becomes cosecant of x. And now, of course, we know both of those integrals. So that's the secant x, and that's a negative cosecant x, and the plus c, of course. That is the answer. All right, for question number 18, what we have is, oh, and I'm using a new app, by the way. So, um, yeah. So just let me know which app you liked better. All right. So we see that in this question we have a cosine square 2x and then a 2 sine squared x, and we know that the formula of cosine 2x, one of them at least, has a 2 sine squared x in it. So we're just going to replace by this, and then of course we have a 2 sine squared x in the numerator, so that and that will cancel to just form the one as I have done over here. So we just have a secant square x in practice, so of course the integral for that is tangent x plus c. All right, now for the 19th question. 19th question is 1 over sine x times cosine cubed x as I've written here. So I'm just gonna write that 1 in terms of sine and cos, so we can just have everything in the same term. So yeah, so I just wrote that out as sine squared x plus cosine squared x, and then we split the integral. So we split it up and we get sine squared x over sine x cos cube x plus cosine squared x over sine x cosine cubed x. So here we see that um, this sine and that power cancel, and I'm just gonna write the first term as that, and here we see that I'm gonna cancel one of them, so this power just becomes a cosine x and that becomes a 2, and then I'm gonna write it out as it is, and you'll see why in a second. Now this becomes tangent x as I've written here, and this cosine goes up to form a secant x squared. So we have again tan and sec classic integral, and here we'll have a cotangent x, but I'm just gonna write that out as 1 over tan x because when we see that this shoots up to the numerator to form secant squared x, and when we have secant we always want tangent, right? So I'm just gonna let tan x equals u and secant square x dx is equal to du, which is what I have made replacements here. So that is u and that is du. So this becomes u du as I've written here, and that is u and that is du. So that just becomes 1 over u du, which I've written out as u to the power minus 1 times du. Then we use the classic power rule here and the standard integral here, and then we replace the value of u, and that is the answer. All right. So then question number 20 is cosine 2x over cosine x plus sine x whole square. So I'm just gonna write cosine 2x because we have cos and sine in the denominator. I'm just gonna write that out as cosine squared x times cosine squared x minus sine squared x because that has both sine and cosine in it. And now I'm gonna factorize the top as a difference of squares. So we know that a squared minus b squared is of course a plus ba minus b. So I'm just writing that out here, and the bottom can be factorized to be two of the same thing like this because it's a square. So the positive terms cancel, and what we have is this. So we can just use the standard u sub here. So I'm just gonna let u equal this. Then du is that. So just making that substitution, it becomes this becomes u and that becomes du. So it becomes du over u, which is just obviously log of u plus c. So logarithm of cosine mod of cosine x plus sine x plus c, and that is the answer. All right, for question number 21, this question has, an inverse function in it, so it might seem complicated, but it's actually really easy. So it's probably the easiest question in this exercise. So what we're going to do is we want to remember from inverse trig that we learned earlier that opposite, like the inverse of a trig function and the normal trig function, these cancel out to just give x. This works with any inverse function, of course, within the specified domain, but here we don't have a domain, but we don't need it because we can just find any integral in this case since it's indefinite, right? So I'm gonna have to write cosine x as some form of sine, so I can just cancel the sine inverse outside and the sine and just have the argument. So we want to recall that cosine of x is sine of pi by 2 minus x, and we can prove this by using the formula for the unit circle or by the complementary nature of trigonometric functions, which states that opposing functions such as sine and cos, we can just subtract each of them from pi by 2 and to form the same value. So I'm just gonna write it out as sine of pi by 2 minus x, right? So of course, the sine and sine cancel out to just give pi by 2 minus x. Then we can integrate because pi by 2 is a constant. That's just going to get an x term. And since x, we're going to use a power rule. And that is the answer. All right. Moving on to the next question. This is probably the most important question of this exercise. So I want you to pay attention. And yeah. So this question is one, and I want you to memorize this, by the way, because it has a very high chance of appearing in some exam that you'll attempt this year. This question is 1 over the integral of 1 over cosine x minus a times cosine x minus b dx, where a and b are constants and x is the variable. So I want you to memorize, the first step I want you to memorize is that we're going to multiply and divide by sine a minus b. And remember, we can do this because a and b are both constants. So sine of a minus b is a constant. So we're just going to multiply inside the integral and divide outside. And then what we're going to do is I'm just going to do some rough work again for you on the left. So a minus b, this is the argument of the sine in the numerator, and we're going to add or subtract an x to it. It's effectively just adding 0, but it's going to help us solve the question, right? And now we want this to look like that for the denominator, x minus a and x minus b. So you can already see that we have an x and a minus b. So I'm just going to write that down. Then we want an x minus a, right? But what we have is a minus x plus a. So I'm just going to take a negative sign outside. So that's going to give me x minus a, which is what I needed. So, so basically that is equal to that. And we can expand this out to c. So that just gives you this, which of course gives you this, which is the original. So it's correct. So I'm just going to write it down as that, exactly like how I wrote it here. So the numerator becomes sine of x minus b minus x minus a. And now what we want to do is we want to recall the formula for sine x minus sine y, which is this sine x cos y minus cos x sine y. And I'm going to apply that in the numerator. So this is sine x in our case, this is cos y, this is cos x, this is sine y. And now we're going to split this integral. So when we split this integral, we see that in the first term, which is that, the cosine x minus a, these cancel out. And what's left is this and that, which when we divide just gives you tangent x minus b. And similarly, when we do the second integral, we see that the cosine x minus b and the cosine x minus b cancel out. We just have a sine x minus a over cosine x minus a, which of course gives you tangent x minus a. And now we are ready to integrate using the standard integral. So the integral for tan is, of course, log of mod sec x plus c. So using that, we get log of tangent sec, log of sec x minus b and log of sec x minus a in absolute value, of course, then a plus c. And now using the properties of logarithms, which is of course log x over y is log x minus log y, we have this form here. So we're gonna uh, re-engineer that to give this form. That just becomes log of secant x minus b and then secant x minus a. And of course, we can convert this to cosine if you want to get the answer in the book, which is because this is the reciprocal of 1 over cosine x minus b, and this the reciprocal of 1 over cosine x minus a. We can just flip the values and write it in terms of cosine. That's just gonna make um, cosine x minus a over cosine x minus b plus c. That is the answer given in the book, but you can leave it at that, and that would be correct. All right. Now for question number 23. I'm so sorry for not doing this live. It was an honest mistake, right? And I'm doing this for the second time in a row, guys, just be explaining these questions. All right. Then for the 23rd question, what we have is this, right? I'm just gonna change the color for you guys, right? So I'm just gonna split this integral just because we can. So when we split it, the first term is of course this, and here we see that the sine and the sine cancel out. So what we get is this 1 over cosine squared x, and the second term is that. Um, oh, I'm so sorry, this is one integral, right? Second term is that, so here the cosine squared x and the cosine squared x cancel. So what we get is 1 over sine squared x. Then we can write this out as sec squared x times minus cosec squared x dx. And we know the integral for secant square x, that is just tan x. And for cosecant square x, it's minus cotangent x, but we already have a minus here. So it's going to become a positive. And that just makes tangent x plus cotangent x plus c, which is your option A. So, by the way, in this question, what you want to memorize is you have to multiply and divide by sine of A minus B, then add an x and subtract an x, and factorize a negative sign outside to get what you want. So these are the 3 steps you have to memorize, and then it will come to you. All right. Now for question number 24, which is the last question of this exercise, guys, which is this. And it may look complicated at first because, well, it does look complicated. But what we're going to do is we're going to expand the numerator first. So when we expand the numerator, this e to the x multiplies with 1. So that just gives you e to the x. And this e to the x multiplies with x to give you e to the x times x. And now we're going to let the argument of the cosine be u. So I'm just going to carry this out again. Remember that the product rule has to be applied here. So the product rule, just to give you a refresher, is that, ignore that. So for the first term, it's going to be the derivative of u, and u is x here. So the derivative of u is 1 times v as it is, so e to the x, plus the derivative of e to the x, which is of course e to the x, and then u as it is. Dx gives du. And of course, we have this in the numerator. That's just going to become du, and the denominator, of course, becomes cosine squared of u or t, whichever variable you choose. So it becomes cosine squared t, and then, of course, the reciprocal is sec squared of t, and we know the integral for that is tangent t plus c, and then we're gonna let t, we're gonna replace t with what we took t to be, so that's just gonna be tangent of x times e to the x plus c, which is your option B. And guys, that's it for 7.3. I'm so sorry for not doing the last part live. I mean, I did record it all live, and then I just realized I wasn't recording my microphone. That bit of a bummer, right? But thank you for watching. Leave a like. Let me know which app was better. And yeah, stay tuned.